Hello, good day. My name is Ibego Jamike Albert. I'm here to make a do a presentation for my recording of for my dissertation. My topic being implementation and design of smart agricultural systems using NT's lab data. I will I would like to give a special thanks to my supervisor, Dr. Pune, and my second assessor, Dr. Jami. So here's the overview of the project. So, with this dissertation, I hope to establish the impact of air quality on agriculture. And we all know that agriculture is one of the most important industries that feed the population, aid in production of raw materials, which are used to make clothing and other things, chairs, our day-to-day life and depend on, and also medication also. And it's also is a source of income to families and to the population as a whole through marketing um, crop production also to sell as a farmer. So, however, it is subjected to numerous challenges, among them being the effects of features in the external environment, which could be like climate change, water pollution, soil erosions, and co. And for instance, the one we're working on at the moment, which is air quality. And we all know that pollutants can have an effect or an impact on farming as and its yield. Then, what is smart agriculture? Smart agriculture, as some experts may refer to it as precision farming or precision agriculture, implies or represents a revolutionary way of farming that makes use of modern technologies and makes use of modern ways to optimize the use of resources to make precise and proper, calculations to avoid wastage of resources and avoid wastage also in the environment. So basically, this involves like using the right calculations to get the right yields, the right amount of nutrients to be delivered in the plant or delivered in the farmland to to give it the right nutrient because you don't just overfeed because you can't just go and put excess amount of manure or excess amount of fertilizer in the air in the farm and expect it. Those are wastages and those can cause very very harmful things to the environment or to the plant itself. So basically this involves the use of technologies like IoT, data analysis and AI and this is used for, and that is data analysis for analyzing and visualization of data, and also AI for the making of model development and predictions, and also sensor networks, just like what NT has. NT has sensor bees in Portland building, Northern Terrace, and then James Graham building. So these are used to read data from off the air. So, and also I would like to explain a little bit of an architecture because they have the sensors which send information to the database, and we have an application layer. So the application layer could be like your CSV file. It's a little bit of a complex. There's more to it, but it's a little complex, but it's relatively easy. So just the sensors, they send it to the data, they send it to the database, which stores the data, and you get to use who stores the database, and you get to use something like an Excel sheet to to properly arrange it and make it visible and much more proper to understand and learn. So for the system we use, the system combines the use of sensors, which is done by NT Lab, and complex analysis and program predictive algorithms to monitor the levels of polluting agents and particulate matters and greenhouse gases in the environment and how it affects agriculture. So the aim of the system is to build an agricultural smart system that will measure conditions of air and in agriculture and how it's related to affecting or not affecting, you know, crop production, and how it will enable farmers to tame the special impacts of climate change or boost of climate change and air or bad air quality, and which will help them boost agricultural crop production. So how do we achieve these aims? What are the objectives? So basically, we monitor documents and levels of prediction of levels of propellant, and that is done by NT lab already with the system, and that's why we are going to use NT data, which is secondary to us. We have to develop models from data, and we have to create visuals. We have to create visuals like scatter plots and scatter plots, heat maps to give a much more presentable um, to give a much more presentable view. So for the literature review, as we all know that the air quality is a very important determinant, or the quality of air is a good determinant of health crops and of the health of the crop, how the crop yield and the production of plants. And, and there's an increase in the awareness to educate people about the dangers of the different lack of paying attention into to air quality and how it may affect you know plant production in general. So there's basically an indirect and direct approach of researching at the moment to the and that's what this literature covers. So at the moment is structured around some major themes, which I will take a little bit a brief of all of them. So we have the air quality and agricultural productivity. This talks more about air quality and agricultural yields. So this talks more about air quality and agricultural yield are normal issues that are interconnected together, a little complex to overlook, so you can't overlook it technically. So here the researcher states that the different pollutant, the different effects of particulate matter or the pollutant matter can how it can be negative, can be on the negative side. So it blocks sunlight and it blocks sunlight from reaching the plants to achieve proper photosynthesis. And also, it also says that those PMs or pollutant matter can help can help in the can help sunlight reach plants to aid proper photosynthesis. So it goes like it says, it's both interconnected and is a little complex to overlook. Then you have the monitoring environmental pollutants in agricultural systems. So basically, this is just using MT IoT devices and sensors to take proper readings of to take proper readings um, of air quality. And also, it talks about also how one of the major overlooked catalysts there could be pesticides and organic compound because they could affect your readings as you're taking readings. Then we obviously know the impact of soil and water and how soil, water, and you could have minerals and metals all over in your water, which can affect your readings also, and had the chemical and there could be chemical waste in your water, which could also affect your reading. Because in an irrigation, you never just pours water and you could have all these contaminated things in your water. And talk about strategies for mitigating negative environmental impacts on agri. So we all know that obviously we have to save and feed the world, but as we are doing that, there's a recoil on the plant on the earth. So or there's a recoil general after every agricultural produce. So as you're farming, you're going to till the ground, going to damage the ground, going to pour pesticides on the air, which is going to spoil all these things just for the production of that plant. So basically, this literature here talks more about how we are going how addresses the situation on how to reduce it. Because okay, like take for example, you have them after there's a team I saw on Ghana who are trying to make use of plantain rides, the back of the plantain and the stems of the plantain, and how they're trying to turn it into cotton. So after all these things, you see that another problem again, which is this ties in together with waste management. Waste management are also part of the recourse because you never can tell where to throw it. You just dump it out there, and affect it could affect it's definitely going to affect the environment altogether, which could decay and also spoil the air also, and not leaving room for proper for the proper nutrients to pass through the air. Just be decays, or compost. So, and also there's another topics which is sustainability of agriculture, balance productivity with environmental health. So, as it's not a good topic to talk about, but the more there are people, the more you need to have more agricultural produce. So uh, these are different literatures that are being talked about. Um. Okay. So for the methodology, we're going to talk about the approach used. The approach used is to find the in analyzing to the correlation between air quality and agricultural productivity using in a smart system. So the major data collection technique here is obviously secondary data because it's NT labs data, and the data mining technology here we use is CRISP DM. So CRISP DM is cross industry standard process for data mining. It's a methodology which is widely used and is more systematic and structured in nature. So the benefits of using CRISP DM is because it's cyclical and iterative in nature. So that permits more reading and more adequate examination and evaluation and evaluation. So and also the next is data collection. Data collection is done through the use of sensors. NT Lab has sensors in those different locations, Portland and Northern Terrace, and James Graham Beauty and other places and other sites too. So for the data analysis, like I said, it's secondary data, and we use both statistics and machine learning methods to investigate the correlation between internal air quality or air quality and agricultural yields. So first of all, we describe the data, we describe the data and get the baseline of how the data looks and the important features of the data. Then from there, we make our way forward to find the relationship between the environment and the crop productivity. And then next is to use um, machine learning algorithms like random forest regressor, which is used to forecast agricultural yields in in from air quality. So I will head over and go to the code and explain more on the code on the. So this was done in Google Colab to to make this. Okay, so I will proceed to give an overview of what is going to happen all through. So first of all, we import the different libraries, which is them Pythons and everything, because those are regarded as like tools necessary for the whole of the analytics and manipulation and machine learning. So first of all, we import those tools, pandas for data manipulation, skate learning for machine learning, and then matplotlib and seaborn for visualization, right? And the next is to load the data. So we're using the 2023-04-28.csv. It's a CSV file, so we're going to use it, and that's why pandas is important. Yeah, pandas is very important because it's going to help in reading the. It's going to help read the CSV file as well. And so data next we're going to do is data.head. So data.head helps to show the glimpse of what what you're working. I'm going to give an overview before I go into more explanation. Then data info provides okay what the column name looks like, the data type, the missing values, data.info, the different columns, their data type. Is it int? Is it a double? Is it a float? It's going to show you the different explanation and give you a more simple info. I mean, then data just describe basically just a summary of your whole column, just summary of your whole data. Then the next is to check for missing values with data.is null. And the next is pre-processing of data thereby you there okay in that area in that situation you just get to handle like missing values, and after that you get to select your features or predictors, and you have to get your target variable. Then from there you split your data into you split it into training and testing sets. So use the train and test split, and also this is also fundamental when you're working on it's also fundamental when you're working on in machine learning to evaluate model performance and on data that are not seen. Then we keep numerical features, so we get to keep numerical features on it. Okay. So you train your model. That's next, and after that, you train your model. You pick an algorithm. As I said, we're using random forest regressor. It's a very powerful ensemble learning method. Then you use other things like a simple imputer to handle any remaining missing data, because you need it. You need to have a very good, almost you need to have a very good set to train your data. Then that's all. Then you fit your models, and after that you make your prediction and you evaluate. Then from there you create a visualization. You have scatter plots. You have your scatter plots to show you the just examples of scatter plots, something like this. Scatter plot. Then you have more scatter plots, and this red line is to show something like a perfect angle or what a perfect thing should be like. So you have your heat maps. I believe there are heat maps. Okay. There are heat maps to get your correlation matrix, which is important. Showing the relationships between each features. So that is it. You have your histogram also. You have your histograms also. Yeah. Okay. So okay. So I'm going to try and explain each tool, not in depth to minimize time. I'm going to try and explain some of the tools. So pandas is used, like I said, is a powerful library for manipulation of data, and usually known for when you want to work on CSV or XLX files, basically Excel files. Then skitlearn, you have the train set, which is used to split your data into training and test subsets. You have the standard and scalar normalizing features. It's used to normalize features. And random forest regressor, you have to call it because you're going to use and train is a you're going to use it for your machine learning model to regress tasks. Then mean squared error and R2 score. These are metrics to evaluate the performance of the regressed model. You understand? So here you data the read, obviously you're reading the SV file, you're reading the CSV file that you're going to use Then also matplotlib and cbond for visualization. Then there's nothing much too fancy. Data info, like I said, is to give you more information. Kind of, is it null, is it empty, is it nine? And it gives you example. Okay, see like this template ID is an int because it goes like that is on the first answer, which is like 1 2 3 4 5 of your. So it gives you the detailed type of your file. Data.describe does it gives you like a basically this is basic statistics. It gives you the statistics of your um like mean, median, mode, which is doing here, um and standard deviation for numerical columns. So it counts mean, standard deviation, minimum, maximum, and that's it. And data is now to help to count the number of missing values in each in each column. And data fill now. So this one basically handles filling of values, fills the missing values by propagating the last observable. So from the last observation, it tries to fill in the new one, the new from the last observation, it tries to fill in the new because you need to have data. You need to have as much data to know um, interval to have a good training set of your model. All right. So thank you so much for listening, and I hope it means well. Thank you. All the best, and I appreciate. Shout again, special thanks to my family also for bringing me here. Special thanks also to my supervisor, and special thanks also to Dr. Jami, because this is her course. DAV. It's in DAV that we learned a lot of things here. All this a lot of all these terminologies and tools used were learned in DAV, which Dr. Jami did teach. Thank you so much, and all the best.